Hi all, I'm Lana, and today we're going to be going over the decision tree assignment for CSC 116. The champions for this assignment are myself, Taisia, Megan, and Snigdha. Let's start off by briefly going over binary trees. A binary tree is a tree with nodes that holds its value and references to a left and right node if one exists. We will be implementing this assignment using binary decision trees. These trees can be used to make decisions where each node holds a property and the left and right values of a node hold either a new property or an outcome or final decision. Keep in mind that decision trees are not necessarily balanced. In our homework assignment, we will be using decision trees to determine animals based on a set of yes or no questions. Each answer to a question will travel to the left or right node of the current node, where we will have to answer more yes or no questions until a leaf node representing the animal is reached. We will be working with two CSV files, animals.csv and questions.csv. The animals.csv file will hold properties of our animals, where each property holding a value of 1 representing yes or true, and 0 representing no or false. The questions.csv file contains two columns where the first column is the property and the second column is the yes or no question text corresponding to that property. The decision tree class will take in two of our CSV data files. In the decision tree class, it is recommended that you create methods that will first build your entire tree, and then call those methods upon the class initialization. You may also want to set up any data structures to store information from the data files. That way you will only need to read each file exactly once. For details on the required methods to implement, refer back to the decision tree homework documentation. Now let's demo the GUI. I'm going to try to get cat. So does it have teeth? Yes. Does it have 4 legs? Yes. Is it a predator? Yes. Is it the size of a house cat or larger? Yes. Does it swim? No. Does it have a tail? Yes. Is it domesticated? Yes. It's a cat. To restart the game, pressing either of the yes or no buttons will automatically restart if the restart method is implemented correctly. To help with debugging your code and enhancing the efficiency, there are a few testing opportunities for you. The first thing that you should make sure works is finding the correct animal. For the first testing opportunity, you don't need to check for efficiency, you only need to make sure that you're able to come to the final animal based on the questions asked. After you've established that you're finding the correct animal, you need to make sure that you're creating a balanced tree. Or as close to a balanced tree as possible for the maximum efficiency. We need to find a feature that most evenly splits our animals. In testing opportunity 2, you should write a method that takes a data structure of animals and their features and finds the feature that is true for as close as half of the animals as possible. This feature will be the next question in your decision tree. All of the animals that have the feature will be part of one of the child nodes in the tree, and the animals that don't have the feature will be part of the other child node. Keep in mind that your method should be able to handle any subset of the animals, so that it can be used to determine the feature for any nodes in your tree. Now for testing opportunity 3, we want to improve the efficiency of our tree. We can test this by playing the game many times, recording the amount of questions asked per game to reach the final animal, and calling a restart after each game. Assert that the average questions asked per game is at least less than 8.0. Thank you for watching and have fun.